Hi everyone, this is task 2 for lab 7 exploring elevation data. In step 1, we need to convert USGS 10-meter DEM dataset to E3 grid format. For that, in step 1, explore q1122.dem using Notepad application in Windows. For that, in step 1, in the Windows File Explorer, navigate to your lab 7 folder where you downloaded your data for lab 7 and then go to DEM folder and then click USGS folder. Next, you want to open q1122.dem with Notepad. For that, right click on the folder and then open it with Notepad. Then you can look the file in the Notepad. And once you are done with observing the information in the Notepad, in step 2, go to ArcGIS Pro and then insert a new map frame. So go to insert and then new map and name the map frame is task 2. For that, right click on the map frame, go to properties and write the name is task 2. Then click OK. In step 3, in the ribbon, click on Analysis, and in the Geoprocessing, click Tools. And we need to use the Copy Raster tool. Input would be q1122.dem. So I think we haven't added it. So you can first go to View and then go to Catalog pane and then go to Folder for Lab 7. First, let us add q1122.dem to the Contents pane. So first find it and then add to current map. So yeah, now you can use the copy raster tool. For input raster, use q1122.dem. And then output raster would be USGS 10-meter DEM. And then format is E3 grid format. Leave all options as it is and then click run. This will automatically add the DEM layer to the contents pane. And then if it is not added, you can add it. In step 4, check the coordinate system of USGS 10-meter DEM layer. So right click on the DEM layer and then go to properties. Next, go to source tab and then go to spatial reference, and you can see the coordinate system. And you can answer question number 3 by observing the coordinate system that's present here. Next, in step 2, we need to convert ASCII file .asc to E3 grid format. For that, in step 1, we need to explore .asc using Notepad. So go to the Lab 7 folder and then find the file first for the ESC. So go to DEM and then go to bathymetry, and then you can open the .asc with Notepad once you find that file. So open with Notepad, and then you can observe the various information. The -9999 is a no data value When you scroll down and to the right, you will see positive and negative integer values. So let us scroll below. So you can see there are positive values over here. Once you are done with observing these values in the notepad, in step 2, again go to ArcGIS Pro, and then we can first add the .asc to our contents pane before we use the analysis tool. So go to view and then catalog pane, and then first add .asc. It's in bathymetry, and then add this .asc to current map. So once you have added that, now you can use the analysis tool. Go to analysis and go to tools, and in the tools type copy raster and then hit enter. And in the input raster, use the .asc, and for output raster dataset, name it bathymetry, and then format is E3 grid format. E3 grid format, and then leave all options as it is, and then click run. Once the tool will run, it will automatically add the bathymetry layer to your contents pane. If not, you might have to add it. And then in step 3, we need to define projection and coordinate system according to the metadata available on the data page. So go to the website that's in the instruction. So once you go to the website, you will find the description of the coordinate system, which is Washington State Plane North feet, NAD 83 and NAVD 88. And then you can go to the zip file and then download it. So you can download G1225480.zip, click it and download that. And then once you have downloaded the zip, you can look for metadata and then open the metadata. Once you have opened the metadata, and viewed the HTML file, you can go to special reference information, and this will give us the information about projection as well as geographic coordinate system information. So you can look for it. So there is special reference information which gives the projection name and the datum name it uses. You can explore this, and once you have explored it, you can again go back to your ArcGIS Pro, and then we need to define the coordinate system of bathymetry layer using the define projection tool. So go to analysis and go to tools, and then type define projection. Input dataset would be bathymetry. I think we haven't added it to the contents pane. So go to view catalog pane, First, let us add bathymetry to our current map. Now use the tool define projection, and then input dataset will be bathymetry, and then coordinate system. And for coordinate system, click on globe and then go to projected coordinate system and then go to state plane and then add 1983 US feet. Next, go to NAD 83 state plane, Washington North FIPS 4601 US feet, and then click OK. And then you can also define the current Z, and for that go to vertical coordinate system, click gravity related, and then go to North America and then use NABD 88 depth feet US. And then click OK, and then you can run the tool. Next, in step 4, we can change the color ramp for bathymetry. For that, in the contents pane, right click the bathymetry and then go to symbology and select the spectrum as full bright color ramp in the color scheme drop down menu. So you can click show names so that it will show you the names, and then search for spectrum Fulbright. And then once we have used that color scheme, we can check invert. This will invert the color ramp so that we will have high values displayed in red, and then low values will be displayed in blue color. And then your layer should look like this. In step 3, we need to display LiDAR DEM and calculate a canopy height model. For that, in step 1, in ArcGIS Pro, add the LiDAR surface and LiDAR ground layers to task to map frame. So go to catalog pane and then go to the folder for LiDAR. And then add LiDAR ground and LiDAR surface to the current map and add it to the contents pane. And in step 2, create a canopy height model to represent the height of infrastructures and buildings. We can uncheck other layers. So go to analysis tab and then go to tools, then go to toolbars, and then in the toolbars go to spatial analysis analyst tools, spatial analyst, and then click math and then click minus. And then in the input raster, use LiDAR surface is the input, and then in the input raster value 2, use LiDAR ground. And then output raster would be LiDAR NDSM. So you can name it. and then click run. Once the tool runs, you can observe that the pixel values of LiDAR and DSM range from -60.6396 to 456.12. So you can zoom to the area enclosed by the red circle in the instruction. In the resulting LiDAR image, the building groups and tree canopies are distinctive from their background. We can use the Explore tool to identify the height of the elevated objects. For that, go to Map and then click Explore. And then you can click on any cell and that will give you the value for the pixel, and you can click other cells also to identify their pixel values. And then once you are done with observing those changes, when you use the Explore tool, for task 2 you need to create map. So you can insert and insert new map first. Again, map, new map, and then we will also need to create layout. So for the first map, we need the layer named USGS 10-meter DEM. So copy this layer to your new map frame and then paste it there. And then we also need another map for bathymetry elevation. So let us copy this layer to next map frame. So go to the map frame and then paste it in new map frame for the bathymetry layer also. And then in the layout, you can use the map frame for map and use the activate tool to zoom it to appropriate scale also if you want, and then close activation when you are done. And then let us add another map frame for bathymetry. And then activate it and zoom to the appropriate scale, and you can close activation once you are done. So we will have one map for the DEM and then another for bathymetry elevation, and you can also insert the legend for this and for this both, and you can add north arrow, scale bar, and then you can give your map title, and then you can also add your name, and then you'll be able to create the map. So include everything, and then you can change the symbology because the default one is black and white, so it might not be good representation. So you can change the black and white to some different color for the DEM. So right click the layer for the DEM, go to symbology, and then choose another color scheme which you think will be better. And you can change the color scheme. And in order to receive the full credits, make sure that you have essential map elements such as name, title, north arrow, and you'll be able to create map for task 2. That's all. This is the end of task 2 for lab 7. Thank you.